சார் இருக்கும். எஸ்.
வருதுல்ல இப்போ இதை வச்சுக்கோ.
ம்.
இது கேமரா விட்டால்
ம். ஓகே சார். எஸ். ஆன்ல தான் சார் இருக்கு. உதய் சார் அப்படியே வரல. உதய் சார், உதய் சார் ஆடியோ வரல. உதய் சார் ஆடியோ வரல. இதுல இங்க பேச கேட்கல. அங்க பேசுறது இங்க கேட்கல. கேட்காதா? சரி சரி, ஓகே ஓகே. வீடியோ கரெக்டா வருது சார். ஓகே சார், ஓகே. அம்மா, செல்லோடேப் எடுத்து வைங்க. செல்லோடேப் நைஃபும்
கத்தி கத்தி கத்திங்க
இல்லையே உங்கள்ட்ட.
அதுதான் அங்க இருக்கு, கீழே இருக்கு.
லிட்டில் மோர்ஸ் இன்னும் கொஞ்சம்.
Here you can look DCDP,
எஸ்
and then this is solar inverter. ACDP is there. So from ACDP you can get a three-phase electricity that you can give to grid. From grid here generating. As of now we have generated this the post area.
எஸ்
So we revenue generated from this panel is almost 2 lakhs by 1 year, 3 months. The installment cost is around 6 lakhs. So 6 lakhs provides 2 lakhs return back by a year. So this is a successful project and we are running in very successful manner.
So this the message that given to the all the listeners here is try to explore the renewable energy, particularly solar photovoltaic. You know, there are a lot of potential. Even not only for I can say the institute, you know, running a project or industry also expected to produce the power from the renewable source. Then they can have more I can say energy for all the I can say energy consumption devices. Also, it's maybe the awareness to the people those who are having a multi-storage building. Let them also explore this kind of system to generate the power rather than depending on the government. So what we say is we are able to get the revenue within 1 year, 3 months of 2 lakhs. What we spend is around 6 lakhs. So after maybe another 2 years, the system is continuously producing the power. Whatever the amount of cost we are spending is not going to be I can say good balance after 3 years. Afterwards, the life training for 25 years. So up to the remaining 22 years, we can be able to get the power free of cost.
ப்ளீஸ்.
Here we can do LCA for particular solar PV system. So that we will work as a tutorial. So here what are the input, what are the output you have to note here, and you have to give that as a assignment. Okay, so note input, output, and what are the emissions are involved for this conversion process. So that is our tutorial. So here we are considering solar energy as a electricity input. So next we will look biomass and then we will compare biomass as well as solar municipal solid waste. 3 things we can compare: how energy involvement, how it affects the environment, how much global warming potential we are generating. So those things and all we can discuss in this.
உதய் சார் அதை ரிமூவ் பண்ணிடுங்க. அந்த ஒயர் பிபிடி போயிடுங்க. அந்த ஒயர் ரிமூவ் பண்ணிடுங்க சார். அந்த ஒயர் ரிமூவ் பண்ணிடுங்க. அந்த ஒயர் ரிமூவ் பண்ணிட்டு எடுத்துட்டு வரேன்
சார். நம்ம இங்கே வந்துடலாம் சார். சோலார் எட்ஜ் பார்த்துக்கலாம். அந்த ஆப் பார்த்துடலாம் சார். இங்கே வச்சு அதை அவர்கிட்ட கொடுத்துருங்க சார். சார் அது ஒன்றும் பிரச்சனை இல்லை. ஸ்க்ரீன் ஷேர் பண்ணிக்கலாம். Yes, sir. Yes, sir. Video. இங்க முன்னாடி நின்னா record. இங்க வந்து நில்லு. வாங்க இங்க வா. இந்த solar energy app பாப்போம். This is a solar edge live monitoring app. So here we can monitor the everyday generation, and we can summarize weekly, monthly. So everything we can do it here. So here, this is our site layout. We can look here. So this is our panel arrangement. So 19 panels arranged in series. So here inverter is connected. That green denotation is inverter. The inverter model is displayed. This is specific app given by SolarEdge. Here we can do lots of analysis. So how each panel is converting, what is the panel efficiency, everything we can look here. So here in the reports, we can take periodic report based on day to date. So everything we can monitor. So right now, the production is on. So today date is 29 November. So generation is started at
45.
Yeah. From 645 onwards, and now it is attained almost 5.5 kilowatt. So here it is 5.5 because today the weather is cloudy, so that's why it's giving 5.5. If you look previous history, it come around 7.58. In peak days, it will come around 8.
You can also see here there's a environmental benefits. 7 kg of CO2 emissions saved.
How much CO2 emission is saved? This calculation is based on our grid electricity CO2 emission. Morning we discussed in LCA, we are taking electricity from grid means that 1 kilowatt hour generate this much equivalent. That equivalent is used here for calculating. By using solar, so we are minimizing the CO2 emission. Similarly, so this is month-wise study, and that dark, navy blue indicates last month November. This blue indicates this November. Sky blue indicate. So these are all the cumulative output. January, February. In March month, we obtained high value 1.7 megawatt hour. Similarly, year wise, we can look quarter wise.
We can generate the report based on our need.
Yes, sir.
Daily wise, hour wise, day wise, monthly wise, weekly wise, year wise also.
In that layout, if you look means you can look the each panel generated output.
Yes.
Today. So that will help to whether the panel is working properly or not. If some deviation is there, small reduction or small deviation is there, then the shadow may be a reason. Or birds may that also affects the factor. So everything we can monitor from lab itself. We need not to go field.
This one is around 273.
Yes. So that panel we have to look. So that need to be monitored. Similarly, Each panel leading we will get by only by through optimizer. Without optimizer, we will get the overall reading only. So here we have installed with individual optimizer.
Any questions?
Vari. Yeah. Type.
Mono
This is a mono perk half cut. This is advanced thing. Monocrystalline is the earlier one, and then polycrystalline came. So afterwards, mono cut, mono half cut. This is mono half cut. Usually call this as a mono perk. Yeah, 540 volt fixed panel. In earlier days, 120 volt, 120 watts panel, 240, 220 only installed. This is 540 volt. 7 cross 4, 7 feet length, 4 feet width.
Every panel series connection.
Yeah, series connection. Already set. 19 panels are connected in series.
So we have the space, right? We have the, so no limitation on the space. We have arranged it so in such a way that all the rays falling on 19 in the same way.
It's a single stream.
Singles.
Sir, in the case of larger production area, news channel I saw some drone are taking the thermal imaging. What's the purpose of this?
Thermal imaging, that also one of the monitoring. We saw
Even
some
cleaning and all, no, you can use drones.
It affects the efficiency.
hotspot, yeah.
Heating affects the current generation. For that purpose, we can't do it.
Here we can monitor, we can identify which panel is generating less. Then we have to, I have to go that
So
panel.
if it is only 19 panels or 20 panels or 50 panels, we can monitor. If it is surrounded in a few kilometers of, like, few acres of land, right? If we go to near to the Kirnoor, they have constructed a very high capacity power plant, maybe in terms of few megawatt. So in that case, you cannot go and watch everything. So you can sense by using some app, you can monitor it. Then wherever you want to find some faults or some bad drop, or maybe there's some sand particles are deposited, you need to clean it. Need to send some kind of device or drone, you can able to send it and clean it. So now the automatic, I can say robotic kind of cleaning concepts are coming now. So it's very difficult to go and manually to do the service and all. So need to depend on the artificial intelligence kind of concept. Robots and all, you can buy it and you can use it for cleaning and all. Periodic cleaning can be attained. So that's because we can able to, wherever you are there, you can monitor that. How much the power drawn given by the each cell and where is the problem at the particular cell. Then you can, from your place itself, you can send a, I can say, drone which can carry the robotic thing, so you can clean it. So all new kind of technologies are coming now.
Yeah.
Any more questions? If there's no question, then we'll go to the ground floor and we can demonstrate the microwave pyrolysis reactor, then the gasifier. Possible, we can run the electrical pyrolysis also. The electrical pyrolysis, no much innovations, similar to our general cooking like thing only. The induction stove, we are providing electrical energy, we're converting into heat. That heat can be used for this one. So there's no much in, I can say, innovation. Microwave, you can really see that now we need a separate specific device to, I can say, operate it by using a quartz reactor or something. We will take it to the lab.
So
We'll
now
go
we can fill this, then we compare. So solar PV system, how what is energy input, what is energy output, how emission, that you have to work out in tutorial session.
We go for converting into conventional power generation to solar. How much you can able to save the, I can say, greenhouse gas emissions, CO2 particularly, that you can able to calculate.
அங்கே ஸ்கேன் சொல்லிடுங்க
எதிர் பேசலாமே அங்க
சார் அது ஜூம் அவுட் பண்ணுங்க ஜூம் அவுட் பண்ணுங்க
ஓகே கரெக்ட். Hi, sir. Please.
Yes, sir.
Okay, sir.
Okay. Yes, sir. Begin.
So the continuation of the tutorial, and we are going to do a demo on how the microwave react the microwave process, microwave energy can be harnessed for producing the oil from the solid material. And we tried with biomass sources and the acids and combination of biomass as well as the plastics, but it's co-biomass process. Then here the energy is given the form of microwave as all know that the microwave is not by using a microtron, we are able to generate the microwave at a frequency of 2.4 gigahertz. The frequency we are able to maintain it, you can get the microwave. And the only thing is in the microwave, you can have the system to absorb the microwave. So we have a different microwave reactor system contains different components. Provision to keep the raw material, provision to send the inert gas. So here this is the reactor. Yes.
No, sir, it will reflect that.
Okay.
Yes.
So this is the actually it's a microwave reactor made up of quartz material. And here before the process starts, they're putting the raw material, the biomass, and the microwave energy can be supplied to the reactor. So in order to absorb the microwave, and quartz is capable of absorbing the microwave, that's the reason why the reactor is made up of quartz. And we found that in the microwave process, microwave by absorbing microwave energy, biomass conversion into oil increases compared with the thermal mode and electrical mode. In order to maintain the pyrolysis condition, as you all know that pyrolysis means pyrolysis. Pyro means in order to break the heavier molecule into smaller molecule, we need to provide the heat. Pyro means heat. So lysis means breaking of heavier hydrocarbon into smaller hydrocarbon. That is called pyrolysis. In order to maintain the condition of oxygen-free environment, we need to supply the inert gas from the surrounding through the by providing the CO2 or nitrogen or argon or helium from the cylinder. The pressure is maintained such a way that the flow of nitrogen will be taken care. So normally the system is maintained at 1 atmosphere in order to keep the biomass in the reactor without any, I can say, without taking out from the reactor. We need to maintain the flow rate of nitrogen in such a way that there will not be any disturbance of the biomass particles. And by sending the nitrogen inert gas into the reactor, will ensure that the amount of heat you are providing from the microwave used for only for decomposing, I can say, breaking down the heavier molecule to a lighter molecule in the absence of oxygen. That is called pyrolysis. Think with that. Wanted to tell you this.
I'm going to add some more point. Actually, this pyrolysis microcatalysator is the capacity of 4.4 kilowatt. This setup is having a 4 magnetrons here, 2 on this side, 2 on that side. So each one having 1.1 kilowatt of that. Each one of that magnetrons producing 1.1 kilowatt of microwave energy. So that generated microwave energy is transferred to your parts material through this waveguides. So this channel is called as a waveguide. From that, the microwave is coming out. So the coming microwave is getting absorbed by your organic material, which is loaded in your parts part. So once that organic material is absorbed that heat energy means, so it will start to oscillate the polar molecule inside this. So the heat is going to dissipate from inner parts to outer parts. So that is the main advantage of your microwave pyrolysis reactor. So it means that they are generating the heat and you are utilizing the heat in effective way. That is a major advantage of your microwave reactor rather than your conventional pyrolysis reactor. Yeah.
So after that reaction, the microwave is absorbed by the organic material you are loaded into the reactor. So you are going to break a hydrocarbon to hydrocarbons. All the salt will be converted into gaseous form. Then we are going to connect I can say, the gases comes out from the reactor to condenser, where there are 2 gases are coming out. One is condensable gas and one is non-condensable gas. Condensable gas, you can be able to condense it by using a condenser. There is 3-stage condenser available here. In order to condense it, you are succeeding water into the condenser. So high temperature gases will be entering into the condenser zone where the condensable gases are condensed at different zones, where the maximum amount of liquid can be condensable gas can be condensed and converted into liquid. Then the remaining gas will be also has application. We can use it for, I can say, it has the energy content. You can use it for producing the heat. Now we are going to give the demo of demonstration of how the biomass is converted into liquid. In that we have for the condenser, we are maintaining a temperature less than the ambient. Water is circulated by the low temperature water circulated into the condenser to get the maximum condensation effect in the condenser.
So before we to start the setup, first we have to ensure the safety of the setup. So this is a microwave energy pyrolysis. So we have to close this chamber effectively. This will cause damage. At the same time, we have to check the water which is setting to the condenser as well as inert atmosphere, so nitrogen flow rate. Whether nitrogen water is supplying into the reactor, that should be in. Otherwise, it will create some pressure inside your reactor that may cause damage. So we have to ensure that the chamber is fully closed as well as water is on as well as your nitrogen production correct. That we have to take when we are going to start this setup. Here we are having temperature program. In that we have to set the maximum temperature. At what temperature the reactor is going to start. That we can set. At the same time, we can set the heating rate. So at the heat rate for that reactor is going to, but that we can set. Based on that,
So the operating temperature of the reactor is going to be assessed by taking the biomass in a 3.3 grams of quantity BJ system, thermogravity analysis method, where the operating window you can able to find out what is the operating temperature which maximum solid to liquid gases form transformation happen, that we can find out from the DGA. From the DGA, we can set the temperature in the microwave reactor. So we are expecting all the solids to be converted to gas at the temperature. Then what is possible for condensation, we can condense it. Remaining thing we can use it for, we can store it and we can use it for non-condensed gas, we can store it and get it for supply.
turning on this reactor. This is the temperature. This is the actual temperature of your reactor. We are having a plate at the we will say that the temperature of the reactor. That is the temperature of the reactor.
of this thermal decomposition is your biooil, biochar as well as non-material. The biooil that we can collect it from your food and gas. Biochar can take it from the water itself. So that biochar can be replaced as the active carbon or other. So all the products can be the temperature is if it's above 150 degrees, we are getting some white color vapor. So that is the gas that we are going to condense into this condensed various stages, stage 1, stage 2, and stage 3. Here we are using the silicon for high temperature. Not you have to load a 200 kilograms. Use some limit. The total
That's it.
cost of the 1.5. So we are over 2/3 is loaded.
That's it.
Maximum go up to itself, we get a water.
Synthetic microwave biology process, reaction rate can be increased by adding some catalyst. So the pyrolysis process, you are getting three products. Condensable gas is not a liquid, non-condensable gas, you can store it, you can use for computing application like can use for heating or using the kind of heat energy for application. Whether the solid material, the residue after the process is going to be available in the microwave hot reactor, that you can take it, that has the carbon, high in carbon, that you can convert into some kind of carbon-based catalyst that you can add into the biomass material so that the amount of energy you are providing to reach the temperature comes from. So that also we have tried. So here the calorific value of the bioil what you are getting is about 28 to direct around 20 megajoules per kg. Now to boost up the bioil yield, you can blend some quantity of low density polymer or high density polymer blended with the percentage with biomass, been able to increase the energy content of here. We tried with the co-pyrolysis. We tried with low density polymer, and we obtained the 1 kg of the bio-oil from the co-pyrolysis process, getting more than the calorific value of the diesel. Most importantly, the density of the oil and the viscosity of the oil by adding plastic on it to the biomass comparatively equivalent to the diesel viscosity of 1.8 to 2.1 psd or sometimes lesser than the diesel. That means you can use that as a fuel for diesel engine directly without any modification. Now, the temperature increases you can see here. More amount of running out. That means the reactor attains the very near to the maximum conversion temperature. We are expecting around 400 to 450 degrees centigrade, the maximum temperature. That fits which all the solid materials, the hot reactor will be converted into maximum gases. About maybe I can say 80 to 90%. The other type of you have seen the microwave pyrolysis, how the power it will convert it into the maximum oil conversion, maximum oil quantity. Here is the other type of superconducting conversion process, which I can say 20 to 30% of the automatic air we are going to supply to the reaction according to the gasifier. In converting solid into maximum gaseous product. Along with that, we are using the tar and the solid material. This is the round of gasification system. We are feeding the material from the top, but taking out the gas that the water of the reactor. In order to supply required quantity of air into the reactor, we are providing the flow air. The flow rate can be adjusted. The flow can be what? And the products of the reaction, they are going to say the gasified product because of the synthetic gas maximum Q1 H2 because of the producer gas or synthetic gas. Then other products are also controlled because they are already oxidizing the fuel. Q1 also comes out, and the temperature of the reactor is still more than the 1,800 degrees centigrade. But the possibility of oxygen management also will come out. But we will need to be I first that's correct. Give the demo. I think the secretary.
We are having a great paint at this bottom of the reactor. There we are loading that charcoal is 150 grams. So there that once that charcoal is ignited, the ready ignition, it takes some time to come the record condition. After the record condition, we got to load the biomass. Once the flow is on, the air is going to suck from flow air. The air which is entering into this reactor, that is flows through the various different fluids, draining, pyrolysis, oxidation, reduction. So once the great reproduction of that is reacted to your biomass, so you produce syngas. So that gas is sent out to your cyclone separator and the filter as well as your condenser. So finally, we are getting syngas, synthetic gas as the outlet of your blower. From there, we are getting that synthetic gas, which is combustion of carbon, CO, CO2, and hydrogen. Hydrogen is less than 5%, not more than that. So that we are getting at the outlet of your blower. What is the purpose of this classification is finding out many ways of using hydrogen. It can be used for, I can say, using the green ammonia. So whether we can use it as a green ammonia as a fuel directly in a fuel cell or in a combustion engine, or we can decompose it, we can say, convert it to hydrogen. We want to take the whatever is stored in the ammonia in the form of hydrogen, going to be taken for these fuel cell. You can look at bio.